Okay, now let's take a look at going between rectangular and polar coordinates that we've been given. So, all right, so let's say that we're given, well, let's look at it in general, sorry. Okay, so our rectangular coordinates are given to us as x, y, and we also know that we can set that up as a triangle like this, okay, where this is our r, this is our theta, this is our y, and this is our x, and we already have relationships between these. They're the same ones that we've seen before. So if you want to get r in terms of x and y, then we know that x squared plus y squared equals r squared. Or in other words, we could write this as x squared plus y squared equals r, okay, if you want a formula to remember. And we also know that we can find theta by using tangent. Tangent equals y over x, opposite over adjacent. Okay, so there's two formulas that we can use, or you can set up the triangle, just like we've done before, to get r and theta if you've got x and y. Now, if you have theta and r, and you want x and y, then we can use sine and cosine. So we know that cosine of theta is adjacent over hypotenuse, and sine of theta is opposite over hypotenuse, or opposite over r. So we can use that. So we would have cosine theta equals x over r. So in other words, x is equal to r cosine theta. And we have sine theta equals y over r. Or in other words, y is equal to r sine theta. So if you have r and theta, you can get x and y that way. Sometimes we write it as r cosine theta, r sine theta. And we've seen that before. We've used that back when we first moved off of the unit circle. Okay, so there's our formulas for going between rectangular and polar and rectangular. All right, so let's look at an example. Let's say that we have, let's say that we've got 2, 30. Okay, so there's our polar coordinate, r theta. So r theta is equal to 230. And we want to find the rectangular coordinates. So we know that x is equal to r cosine theta and y is equal to r sine theta, and all we have to do is plug these in. So we're going to have 2 cosine 30 and we're going to have 2 sine 30, and these are values that we know. If you don't know them, if they're not on the unit circle, then you just put them in the calculator. So cosine 30 we know is square root of 3 over 2. The 2's are going to cancel and we get square root of 3, and then sine 30 is 1/2. And that's going to give us 1. So our rectangular coordinate would be square root of 3, 1. Whoops. Okay, so that's going between polar and rectangular. Now the other direction, let's say that we're given rectangular and we want to find polar. So let's say that we have the point 3, -7, and we want to find, this is our xy, and we want to find our polar. Okay, so we're going to use, you can draw a picture if you'd like. It might be helpful, especially when you start doing this. So we've got 1, 2, 3, 2, 3, 4, 5, 6, 7, because it is important to notice which quadrant you're in, Okay, so there's our point 3, -7. And you can either use the formulas or you can set up your triangle and solve it just like we've done others. So there's 3, there's -7. Okay, and we know that r, we're going to find r from the Pythagorean theorem. So we've got x squared plus y squared. So we're going to put in 3 squared and -7 squared. So that's going to be 9 and 49. That would be square root of 58. Okay, so square root of 58. Oh, that's going to reduce any. Okay, so there's our r. And then to find our theta, we're going to use tangent theta equals opposite over adjacent, or y over x. And in order to find this, we're going to have to do inverse tangent. Okay, now this is not a value we know, so we're going to have to use our calculator. And when we use our calculator, we get -66.8 degrees. Okay, if you have to use your calculator, it's easier to be in degree mode to tell where it is. So we get negative 66.8. Now, when you do this, you've got to remember that your calculator is actually giving you a reference angle, and you've got to decide if that's the angle that you actually need. So negative 66.8 is a negative angle, and that does put us in the fourth quadrant, and that matches our picture, that matches our rectangular coordinate. So we can use this one. We can use square root of 58, negative 66.8 degrees. Now, if they tell you to find a polar coordinate where your theta is positive, that's where we would use our coterminal angles, and we would add 360 to this. Sorry, I left out my negative there. We would add 360 to that, and we would get 293.2. Squeeze that in there. So another point that we could give is 293.2. Okay, and there's another video about going between different versions of polar coordinates as well, if you want to see some more of those. Okay, so that either of those would be answers depending on what they're asking you. Okay, let's look at one more of these examples. So let's look at -3, -4. Okay, this is our xy, and we want to change this to r theta. So let's go ahead and draw a picture. 1, 2, 3, 1, 2, 3, 4. Okay, so we've got -3, -4. Okay, so to find r, we're going to do Pythagorean theorem. So -3 squared, -4 squared. That's going to be 9 and 16, which is 25, and that's going to come out to be 5. Okay, or you can just remember 3, 4, 5 triangle. So our radius is 5. And then to find theta, we're going to do tangent theta is equal to opposite over adjacent. So we're going to have -4 over -3 or 4/3. So we're going to do theta equals tangent inverse of 4/3. Okay, so when we put that in the calculator, we're going to get 53.1. Okay, and again, remember that's actually a reference angle. So inverse tangent is only going to return fourth and first quadrant values. So when you look at this, this is a first quadrant value, but the problem is our point needs to be in the third quadrant. That's the other place that tangent comes out positive. So we've got to figure out what theta needs to be for this to be in the third quadrant. So this is our reference angle. Third quadrant would mean that we're doing 180 plus the angle. So 180 plus 53.1. So the angle that we want is 180 plus 53.1 to put us in the right quadrant. And that's going to give us 233.1. Okay, so for this one, 5, 233.1 is the correct answer. Okay, so when you're going from rectangular to polar, you've got to be a little bit careful. The answer that you get might not be the answer that you want. But when you're going from polar to rectangular, you just plug in the r cosine theta and you're all set.